Okay, so welcome everyone. So today is the first seminar of the new cycle, and we have Luca Franceschini, who's a PhD student here in the second year. Luca works on programming languages and especially on runtime verification of programs. But now we can talk about a programming language from JetBrains, Kotlin, which is designed as a new and better Java compatible with Java. So let's hear.
Thank you. Yeah, so this has basically nothing to do with what I do in my PhD. But last year we had one or two talks about tools like Vanessa's ones, and I thought that was nice, so I'm trying to do the same. And I'm going to talk about this language I ran into in the last year. And it is getting more attention from the industry than from academia, which maybe is nice, I don't know. And I was at the Kotlin community conference in June in Milan, and I think I was the only guy from academia, which was weird, but I guess it's also a good sign. The title is not me claiming that it's actually better than Java, it's how they present the language. It's meant to be some kind of replacement. It's made by JetBrains. Probably many of you already use their tools. It's a Russian, I think, company making tools for developers like IDE, plugins and stuff, and they're good at it. They made quite some tools like IntelliJ, PyCharm, ReSharper, which is the AutoMagic auto-completion plugin for Visual Studio. And so this is just to say that it is made by people that usually know what they do. It's not made by someone in a week because Netscape needed, like JavaScript, or it's not made like from a random guy in his basement like PHP. It should make sense. Every time someone starts talking about a new language, there is always someone saying, yeah, there are already quite a few of them. Do we really need a new one? Sometimes the answer is actually no, but in this case, I think there are a few meaningful goals that were set for this language, at least as a more modern replacement to Java and JVM languages. So its main goals are a concise syntax, which is slightly different from Java. It's still object-oriented. I didn't write it here, but it runs on the JVM. It is statically typed. That is somehow different from a lot of languages that are widely used today. It's meant to be multi-platform, hopefully a bit more multi-platform than the JVM was. But it's still fully interoperable with Java. So that allows to gradually move from Java project to the use of Kotlin. And it's designed in a way such that the IDE can always help you. If you ever use like C++ and templates and stuff, you know that that's not always the case. So just a disclaimer, I like Java, it's fine. Still, it's been around for a while. They had to keep backwards compatibility, so there was a pretty hard limit on the things they could add to the language to make it better. So Java is fine, but if you ask developers what they think, most of the times they're like, it's too verbose, I have to write too many things. So probably anyone of you here use Java, but in case you don't, what they mean is that suppose you have to write a class, the code itself is not really important, just the structure. You start by writing the class with a few fields, then you remember they need to be private, then you remember you need a constructor because otherwise you cannot create objects of that class. Then you remember that Java has nulls, and most of the times you don't really need them, so you start adding checks here and there to avoid nulls. Then, since things are private, you add the getters, which are always the same. Then mutability is bad, so you add some final here and there. also in the class, because inheritance is hard to do correctly, and most of the times you don't really need it. Then you need equals, but you also need hash code, but you also need to string. So you basically said nothing here. You just said that the student has an ID number, a name, and an email. But in order to make the objects of this class work correctly with the standard library and with the rest of the world, you have to do quite some things. This is what it's usually regarded as boilerplate. So that kind of code that you almost always write, it's almost always the same. It can be very often automatically generated from your editor, which makes you think, why does it need to be written in the first place? So for instance, the kind of thing that Kotlin does is like this. So data classes are an abstraction, are a special kind of classes that does all the things you usually need and expect from a class without writing them. And for instance, you can just write the fields you need for the class, and it gives you all the things I show, like constructor, null safety, immutability, getters, equals, hash code. You can also copy objects. Oh, there is also the copy in Java. It's weird and badly implemented, but it's there. And also, the Kotlin code is full of these val and var things. So val means that something is immutable, it's a value, and you can change this into a var. It means it will be able to change over time, so it will also generate setters in that case. And yeah, so I think this is nice when you have to like work with a DB and you have all those bunch of classes that represents entities in the database and stuff like that. And speaking of classes,
just one question.
Yeah, sure.
So there was also the issue about private, public. So
Yes.
val, what does it mean that it's also private?
It's always private by default, regardless of it being val or var. If it's mutable, it also adds a setter. Otherwise, just a getter, but it's always private.
Okay, so you need public if you want things to be visible.
Actually, you don't, because there is some syntactic sugar such that you don't invoke the setter. You just write x.field assign blah blah. So you just use it like it was a public field, but it has the check it has the getters. So how does it work? Object orientation in Kotlin. Everything is an object, and there is just one hierarchy. It's not like Java when you have primitive types and object types and some kind of boxing, unboxing, and stuff like that between them. It's just one hierarchy. The top is any, which is a class that is similar to the object class in Java. There's also a bottom, I think, not very useful. There are no primitive types. I wasn't sure about this, I had to check, but it's actually like this. In Python, they can have a special implementation, but as a programmer, you can use anything as an object, and it's the same here. Of course, under the hood in the JVM, they will have some kind of special implementation such that everything runs in a reasonable time, but at the language level, they're all objects. So there are no weird implicit coercions or conversion going on under the hood. If you ever use JavaScript, it probably bites you at some point, because you can do anything and some things, but the result is usually not what you think. And usually you don't need explicit conversion either. For instance, if you add an integer and a double, and you store it in a variable, and you don't write the type, you let type inference do its thing, it works, and you put the double there because it does type inference and the operator are overloaded. So it knows that if you give it a double and an integer, the result must be a double. So there are no weird things going on there, usually. And all the classic object-oriented stuff, abstract classing, interfaces, enumeration, and probably something else I forgot about. Yeah, so I talked about the static types. Usually, static typing and conciseness, which are two goals of Kotlin, are often considered opposite. Like you won't find them in many languages together. That's not the case, and simply because of type inference, it is quite good. So it can infer generic types, like this is of course a set of integers, and it can infer generic types, like Java 10, they just added it. There is, I always forget the name of this thing, this structuring assignment. So if a student object is made of an ID, a name, and an email, you can do like this, create three variables, and it infers all the types. You can combine these with every other structure in the language, like for each and stuff like that. And it has some support for functional programming with lambdas. So here you're asking for the max of this set of strings. So he knows that he expects a comparator, which must be a function. He knows that this comparator must take two strings because we gave them a set of strings. So you can use them as strings here. He checks that you're actually returning a Boolean and stuff like that. So the inference is actually quite good. Uh, it goes even further, like it does what is usually called in programming language design flow-sensitive analysis. So it tries to understand that if you happen to be in that portion of code, you can use what you know from the previous lines in some sense. So for instance, this is the Kotlin equivalent of instance of. Let's assume x is an object. You ask yourself if it's a string, and if so, you do this. This is only legal if x is a string, but you're not doing any cast here, because it knows that if you arrive here, then x must be a string. And this is true in the body of the conditional statement as well. Not that you can trick it easily, because if you try to change x here, this won't compile anymore. So it's smart enough. Another annoying thing about Java, at least for me, is that you always have to check for nulls and you almost never need them. By default, there are no nulls in Kotlin. So if you try to write something like this, it's a compilation error. It doesn't let you do that. This means that you don't get random null pointer exceptions from library or your code or from places. You don't have to write null checks as well, which are it's boilerplate. And everything is checked for nulls at compile time, so it's statically checked. Still, if you really want nullable types, there is something like C# nullable types if you use them. So you just append a question mark after the type of the variable, and you can now store the null here. It's not like you put a question mark and you can do whatever you want to do. There are still some guarantees and does some checks. So for instance, if you try to do this, it gives you an error, the compiler, because basically it's saying this can be null, so you shouldn't really be doing this because it can throw a null pointer exception, and it cannot happen. So there is a whole bunch of operators that let you use nullable types in a way that you don't have to make everything nullable in your program. For instance, there is the safe call operator. So they like question mark apparently. So you can do like this, and it does what you write, what you wrote, if there are no nulls. Otherwise, it returns null. So the result is a nullable type, but it doesn't throw null pointer exception. There is Elvis operator, which I think is a very cool name. It took me a while, but if you look at this from this perspective, there is these things that looks like the ear of Elvis. It's bullshit, but you can do this, and this means if student is not null, then take its email. Otherwise, take this other default thing I gave you. And if for some reason you're really positive there's not a null in here, but the type system cannot understand it, you can just do bang bang and tell him turn these into a non-nullable types, into a standard Kotlin type from now on. Of course, this will throw a null pointer exception if student is null, but you asked for it. So. And there is again flow sensitive analysis. So if student is a nullable types, here it won't be a nullable type anymore. Here it will be a standard type. So this is nice. So yes.
What about multi-threading?
With nullables.
Yeah, I mean, if another thread can change the value of student while checking it.
That's a good question. Let me think if I have the answer. Usually, the way you do multi-threading in Kotlin is with coroutines. So they are syntactically, I mean, the compiler can understand the portion of code that will that maybe will run in parallel. So I think that's when it stops doing two smart things. So if nulls are so bad and they're boilerplate, blah blah blah, why should you use them in the first place? The most convincing answer is Java. You still want to be interoperable with Java, and Java is nulls. So this is the main use case for nullable types in Kotlin. The standard thing to do is you can just import classes from packages. This is a Java package, you just import it and you can use it and everything is fine and it works. It's really transparent. The smart thing to do is to put the result of this into nullable types so that the Java types will fit nicely into the Kotlin type hierarchy. And it goes further, maybe a bit too much. There is quite some syntactic sugar. So, for instance, in Kotlin, when you write a setter, you don't write x dot set blah blah, and you give something as an argument. You actually write it as a property, as in C# and other languages. So you just write x dot property assign the expression, and it tries to be very smart, such that if there is set something in Java, you can use it just like dot something assign in Kotlin. So I'm pretty sure there is some way this can go wrong, but I couldn't find a counterexample. It sounds too smart. But another thing they put a lot of effort into is multi-platform. So Java was supposed to be multi-platform, and to some extent it is. It runs on the Java virtual machine, and you can implement the Java virtual machine for quite some platforms. We don't actually do everything in Java for every platform today. It worked to some extent. So they learned a lesson in some way, and even if they run the JVM, they can also target JavaScript after compilation. They can produce native code. They can work with Android very well. There is official support from Google with respect to Kotlin, so it works well. And this is how they plan to be more multi-platform than Java. Of course, it's too early to see if they're right or not, but this is the idea. There is also some language support for multi-platform projects. In particular, modules are like packages in Java, and there are two kind of modules in a multi-platform Kotlin project. There are what are called common modules. So that's pure Kotlin. You can just use Kotlin libraries, and it's standard package. But you can declare, not define. So just give declaration of classes and of function of some platform-specific code. So you can declare some function that you expect to be implemented differently on different platforms. And then there are platform modules. So it's a different kind of packages. You can still use Kotlin, of course, but you can also use Java if it's a module for the JVM. You can use libraries that are not only in Kotlin, but in the language from that platform. And here, this is where you put the implementation of those declared code. So for instance, This is nothing new, by the way. I mean, the idea to declare things somewhere and implement it somewhere else has been around since at least C. So, you can say things you expect to be implemented. This is the common code, and this can just be Kotlin and use Kotlin libraries. This is the platform code. Here, for instance, you can import the libraries from Java. You can use them, and you can give the definitions of these things. Why should you do this? Well, there are some so it's good to share your code among different platforms, but you cannot do it always. For instance, for the user interface, it doesn't make much sense to share the code, to share the interface among different platforms. So that's the main use case for these kind of things. Yeah, so conclusion. I think that the nice idea about the language is to use again static typing, but understand that people don't like to write types. So to make it easy to write types while still giving the static guarantees that everyone likes, hopefully, in such a way that it doesn't get in the way of the programmer. Null safety, it's nice also. Null have been around for too long, in my opinion. And the syntax is very nice. So I didn't show a lot of syntactic sugar, but there is. For instance, you can, if you're familiar with functional programming, you can do pattern matching. So you can declare a superclass and say that it has a limited set of subclasses that are made in a particular way, you say, which fields are in and so on. And then you can, for instance, write a function that does pattern matching. So it is an argument of the superclass, and depending on which type it is, it does different things, like OCaml, or Haskell, or F#, or every functional language. There are still some things I don't like. If you remember, when I show you the very small example of interoperability with Java, I told you that it's important to assign the result of the Java call to nullable types. This is because if you don't do it and you let type inference do its thing, it does something weird. So in Kotlin, there are standard types that cannot be nulls, and there are nullable types. Actually, there is a third kind of type that it's not really needed, and they're not null. They can contain nulls, but the compiler will not complain. And that's the type that Kotlin uses by default when you call Java code. I think it's a bad idea. The rationale is that they don't want to force programmers using Java to use all those weird operators with a question mark, and I don't really know why they do this. It would have been nice, in my opinion, if they just stick with the nullable types. It sounded like a good idea for me. There are other nice things in the language that I didn't put in the presentation to keep it short. Coroutines are the way Kotlin mostly do parallel computation. You probably use them like it's similar to C# async and await, for instance, and that's a more lightweight way to do parallel computation without explicitly talking about threads and processes and stuff. And it works for most things. Otherwise, if you want all the full-fledged multi-threading library, you can always use the Java library. It's there and it's interoperable, so you can still use that. And this is all I have to say. Thanks for listening.
Some questions.
Yeah, sure.
About question marks.
Okay.
So is this question mark a type constructor in the sense that they can apply it more than once, or it's more like an attribute of variable?
It's a type constructor.
So put several question marks after the other, what happens?
I don't know.
But
I'm
the
not
effort
sure,
is
but
to add null to the set of values, so why should you want to apply it more
If
than
it's a
once?
type constructor, I can apply
Yes, you
to
can.
anything.
yeah.
Well, I'm asking whether the language allows to have that, because if I can apply now to a type variable, then I can replace with the type variable
the
with
thing is
another
that
type.
I don't think it's really a type constructor because it's not an operator. You declare a type, and when you write the type of the variable, you can either write it normally or write it with a question mark. So unless you do very weird things with generics, I don't see how you can do that.
Okay, so it's more like an attribute that you attach when you declare a variable rather than when
Yeah,
you
but
write.
yeah, what I'm
type.
saying is that you only use it at the type level, not in expressions. So I'm not sure how would you generate a nullable string, for instance.
And I guess if you have a generic class that
Exactly.
uses the
Only with generics, I think you can do that.
I guess, yes.
For example, can you have a generic class that has maybe in a method the parameter with null, like the method returning x null if x question mark if x is a type parameter, or you always have to write it next to a class name? I mean,
No, I didn't understand, sorry.
no, so if you have a generic class, then you have the methods inside, and in the type annotations you can have the parameters of the generic class appearing, like the x, and can you write x question mark or something like that? So
You
have
can
also
instantiate
a variable, or you can instantiate.
You can instantiate with the nullable types, yes.
But you cannot write, you can never write parameter question mark in some annotation. I mean, it's only something you apply to a concrete type.
Let me think.
Because that would be the case. Probably it's not.
I think, yeah, that you can. You can write, you can be parametric with respect to a nullable type. But in that case, I don't think that helps to create the nullable because if you instantiate it with a nullable types, it's subtype already. So it doesn't add an indirection of it. So.
The other question was about templates. Does this have templates?
Yes, there are generic, there is parametric polymorphism, and it's more similar to C# ones than Java ones. So Java generics have the wildcards. Every time you use a generic type, you can do T extends blah 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 or things like that. So that's useful to use the same generic class sometimes as covariant and sometimes as contravariant. Here you actually say if you want it to be covariant or contravariant when you define the class. So for instance, if you write a class of read-only list, then you say in because you want it to be covariant. But if it's a read-write list, you don't do it, and you cannot use subtyping. So this is like, I don't know if I was clear, so I try to say it again. Sometimes when you use generics, you want to use subtyping, and sometimes you don't. For instance, if you have an array of I need I need a nice example of subtyping. Yeah, fruit and
apple.
okay, nice. So if I have a list of fruit, I want to be able, if I use it read-only, I want to be able to put an apple inside it because an apple is a fruit, and because I'm using it only for reading values. If I start using it to write values, that may not be the case and things will not work out in the end. So sometimes you want subtype to work with your parametric types and sometimes you don't, depending on the class you're writing. In Kotlin, you specify it when you define the generic class.
On the curiosity, and what about reflection? That Kotlin has some reflection support, or? Because I was wondering, you show the case you can unwrap a class by field, so students ID, email.
Yeah, but that's only type inference and static things. It doesn't work by reflection. It just look at the type of the expression on the right side of the assignment.
Okay.
It understands it's a class. It looks at the definition of that class, and that's how it works. That's not reflection.
Okay.
It's just static type
So
inference.
it's going in the declaration of the
Yes.
Okay. And so that's why I'm asking about if there is some kind of reflection.
I never saw it. It runs on the JVM, so when you run there, I think it probably has some support for reflection. I never used it, but it works on the JVM, so I guess it's available. But maybe only in maybe only in the modules that are supposed to go on the JVM.
Okay.
That's a wild guess.
I would have expected that static typing
Yeah.
doesn't
I mean, it's the same. It's the same as Java. It's statically typed, but there is reflection, and if you start doing that, if something goes wrong, it's your fault. All right. Abbiamo la focaccia.